Okay. And then Twitch is active. Twitch. There we go. I think we're live. Alrighty. Hello, everybody. Welcome back into the stream. I hope you're having a wonderful day. Hey, programming. Hey, Sand. Thanks for joining me here and leaving a message. Hey, Dat Steel. You're the goat. Welcome, dude. Welcome back. Hey, guys. You guys are quick. Quick. You guys are fast, let me tell you. Alright, you guys. Hope everybody's having a good day so far. I am going to try to solve this MIT problem set 2 again today. Yesterday we failed pretty bad at solving this one. We got, pretty decently far just through some concepts, but we actually weren't able to implement the TFS algorithm like we were hoping. So my goal for today is to try to implement it and see if I can do it. So let me know if you guys have any questions regarding where we're at. We're going to be jumping back into the MIT Open Courseware 6.0002, right? We are on the assignments. We are on problem set 2 here, fastest way to get around. So we are coming up with halfway done with the course about. We got to just finish this problem set before we can move on to the other lectures. So this is our bottleneck right now. So every day that goes on without us finishing this problem set is a day that we extend out the course. So we need to get this done and, just move on. So let's go ahead and see what we can do today. I've written out some pseudocode to try to help me today to hopefully follow a little bit better regarding this algorithm for get best path. I'm probably going to just restart my entire process that we did yesterday. Okay, let's go ahead and jump into this today. I'm gonna grab my pseudocode. Okay, so what is the first thing we need to do? Okay, the first thing that we need to do in order to implement this in order to implement this get best path function is we need to implement our step 1, right? So comment, we'll say step 1, right? Which is going to be add current building to the path, right? So right off the jump is you're giving a start position. So for the beginning of the algorithm, you're going to add the initial building to the path, right? So we're going to say if start not in path index of 0, right, which is the path of nodes, then or buildings, we're going to add path index of 0 dot append the start node. Okay. Now our step 2. So step 2. Our step 2 is that if start is equal to end, we have reached our goal, right? We have reached our goal. So our goal, return a tuple with the shortest path from start to end. So a tuple with the shortest path and the distance of that path. Okay, so in this case, we're going to return a tuple where the first entry is path index 0, and we're going to take a copy of that so we don't get reference to the or alias of path index 0 in memory. We want to grab a new reference, and then we want the length of this path, which is path index of 1, right? Because path has this first int, which is the total distance traveled. Okay. So then step 3 of this algorithm is to loop over each edge starting from quote start, right? So we're going to say for edge in digraph dot edges, right? And we're going to okay, so let's say that edges equals to the digraph dot edges key of so this is if start equals to end. We're going to return edges equals to digraph edges of a key of our so start node and then end node, right, equals to node of end. Edges is going to be the start node hash okay, and we're going to loop over all the edges. Okay, so we're going to say for edge in edges, right? Next start node is equal to the edge dot destination, right? And we're going to say total outdoor total time so far is equal to our path index of 1 plus equals to Right, yeah. And we're going to increase the total time so far within this edge dot total distance right, and then we're also going to okay, and then outdoor time so far equals to path index 2 plus edge dot outdoor distance. Yeah. So then what we're gonna do so we need to don't allow cycles. So if next start node, right, in diagraph dot nodes if next start node in diagraph.nodes, then we're going to continue. We don't want to use this node, right? And then don't allow exceeded outdoor time. So if outdoor time so far is greater than max outdoor distance, then we're going to continue. Now so we need to also skip if we have a distance so far that is greater than our best distance, right? So skip if distance so far is greater than best distance found, right? So if total time so far, well, first, so if best distance is none, right? If best distance is none, no, we don't want to skip if it's none because we need to assign it. So not none, meaning we already have a best distance found, and best distance is less than or equal to the best distance, or less than, no, and total time so far is greater than or equal to the best distance, right? We don't care. It's not, we've already have a one that's better. We're going to continue, right? So we know that this function above, this base cases are going to return the tuple. So we need to receive the tuple back on the recursive call here after we got done pruning out our conditionals, right? So we will say so we're going to receive a result path, and we're also going to receive a result total distance, right, is equal to the return statement for the get best path recursive call, where we set digraph equal to the current digraph. We set start equal to next start node, end equal to end, dot name, right? And we'll provide the current path, right? New path with updated distances. So what I take, we're adding the start node to the path. So this would just be the path that we're currently on. We have a new path. And then we have best distance. And best path. Right? So if results path Hey, thanks for coming in on Twitch, dude. How's it going? So if the recursion found a valid path, so if we found a valid path that was given back to us on this recursive call, then we're going to compare this path if the best distance is none, or result distance is less than best distance. So if none and result total is less than best distance, we're going to set best path equal to the result path, and best distance equal to result total. Right? Now, so return best path, best distance. Okay, I think that does it. So implement directed DFS. Find the shortest path. So to implement the directed DFS, we would need to call the load map function on the map file. Hey, I've just been trying to teach myself how to program, and I thought that why not just document the progress along the way? So I've been doing it for the past year as I've been teaching myself how to code. So now if we want to return the shortest path, so we would just need to call get best path, return get best path on the digraph, right? Start, end, max total distance, and then max distance outdoors. Okay, getting some errors here. So we'll say this says path length, path and distance is equal to this. We'll say if path return arrays value error. DFS error. No valid path. Okay, so Where are we going wrong here? Let me see if I can control Elvis. Got unexpected keyword argument max total distance. Type error. We're getting that for all of these? Yeah. Okay, so we're getting a type error for max total distance. Get best path gun unexpected keyword argument. Let's try this. Start. Max total distance. Missing 2 required are in best distance, best path. Oh. So we need to say okay, so let's do this. So diagraph equals to the diagraph. We want to say start equals to start, end equals to end, path equals to a list with 0, 0, max distance outdoors equals to max distance outdoors, best distance equals to what could I set the best distance to? Right, and then best path is equal to 0. Best distance. The best distance that you can currently go is the max distance, max total distance. And the best path is just an empty list. So now if we run key error. Okay, we're getting a key error on our hash for the node. key error bound method node hash 32. So what if I just make the node key error? So what if I just say start key error? Right, you need a hash to find the edge. Still getting this key error. Map not found. Okay, so map not found. So let me quickly update the path. Copy relative path. And then let me make this be relative path. Valid path. Add node error caught, node already in destination. Shortest path from building 32 without walking more than 0 meters outdoors. Loading file. And then multi-step failed here. We've raised a value, our path is now no value. Curious. Okay, so let's take this and see if we have any potential errors here. So if the start node in, not nodes, but in the current path, right? So maybe we're not supposed to hash. Add edge takes the new edge. Okay, so if we just say edges is equal to digraph.edges, right? So if we instead say we have this method here, this get edges for node. So we'll say for edge in digraph dot get edges for node of start node, right? Premise path and the best distance is none, or the rest total is less than. So then if I go here, key error, return self.edges node. So I have to get hash. I thought we have to use the hash. Stir object has no attribute name. Here. Start node in path index 0. If next start node here. The stir object has an attribute name. Stir object has no attribute name. Stir object has no attribute name when we try to do this. If next start node in path index 0. So stir object, which is this, next start node. Okay, so then we have to say node, next start node. Where is this going wrong? Okay, so start to the path. So then maybe let's just keep this. And then let's just add in your object has no attribute name. It's trying to compare nodes. So if we call node on this destination, this slight error here. Node on start. Ready? And we're going to hash the start node. And then we're going to create a destination node. And we say if the next node is in the current path of nodes, we're appending start here. Say node start. Max distance outdoors for get best path. Path. Max distance outdoors equals to max distance outdoors. Object has attribute name. Where? So I'm creating a node and I'm adding it to the path. Let's say. Okay, is if start node in path index or append start node. If start node equals to end. Start node hash. Next start node. Start object not callable. Oh. Huh. 1, 4, 12, 32. Okay, so then we just want to return shortest path of start node. So we just return the path. Right. If path, we're going to return path, else freeze value error. Sure, object is not attribute name. So say if path is none. Let's take our get best path. We're close, I feel like. Let's see. Get some feedback here. Path index 0 contains node object, but sometimes you're passing start and end as strings. So it says path index 0 contains node objects, right? But sometimes you're passing start and end as strings. Okay, so let's just do this. Let's just say if start, not in path, we're going to append the start. If start equals to end, we're going to return path. Else, we're going to call node of start hash right? And then that'll give us the edge, all the edges. Then we're going to edge.destination is the next start node. if new start node in path index 0 will continue. If next start node, so next start node is equal to edge destination. So I'm going to print next start node here and see what happens. There are kids like screaming outside. You guys hear that? Holy cow. Am I even hitting this? Yeah. $36. So if I say, what if I say print type of next start node? It's a node. Okay, so then let's say it's if next start node dot name in path. No way. What? Okay, so let's get it. Get edges. Get edges returns edges for a given node. And edges is a dictionary. Int object has no attribute in your name. Okay, next start. Now I wonder if I have to stir. Here's 32. Let me print diagraph here. So my load map is creating a new diagraph. It's calling add node to the new map. So diagraph add node to the map. we get a hash. And we save into edges the node's hash into edges. So why am I getting a key error now? Int. So we need to say stir here. And object has an attribute name. Int object has no attribute name. And where's that at? Line 88. Go. 139. Here. Return self.edges of node. What happened to the YouTube chat? Why is it not popping up? Where is YouTube chat? Oh, bruh. Sorry, you guys. Hey, Havoc. Hey, Hall. Hey, Shadow. Hey, Marty. Hey, Pineapple. Hey, Tim. Bat Steel. Sorry, you guys. I thought I activated it earlier. I don't know why it deactivated. Sorry, you guys. No wonder chat was dead today. My bad, y'all. So why am I getting... See, the thing is get edges for node. I'm gonna do this. Okay, so let's say for edges in diagraph dot edges key of node start hash right? It'll give me a start node. And if start node, if next start node hash impact. Okay, so we need to start equals to node start, end equals to node end, right? If start not in the path of nodes, we're going to append the start. If the end and the start equal to one another, okay, we're going to do start dot hash. Next node is a node here. Next start node hash. If next start node in the path oh my gosh. I have no idea what's going on here. Your edges dict is key by node object as intended. This won't match. Comparisons later. Edge and 9. So for edge and digraph dot edges, let's say get edges for node start, right? The start node, and then we're gonna append the start node. Key error 32. Let's see. Getting frustrated. self edges node. Get a key error here. See, edges is a hash though. So we have to hash here. The edges this goes. So then what is the deal with this? Ugh, I'm so done with this. The hash to get the edges. Here's the start. Right, next start node. Destination time. Let's pass a copy of the list. And here's just getting key errors. Which doesn't make any sense. Your digraph.edges is keyed by node objects. No, it's not. It's keyed by hash. When you call get best path initially, you start and end as strings. So we'll need to say if not is instance of start of a node, then we're going to override it. And then we'll also say if not is instance end of node, then we're going to overwrite here. Still having problems. It's just problem set 2 of MIT 6.0002. Still getting these here. So for edge, so let me go like this. Let me do this for edge. I'm going to do print diagraph.get edges for node on the start. I'm going to say the object has an attribute name. See, this doesn't make any sense. Add the current building to the path. So start not in path, then we're going to append start if they're equal to one another. Okay. Then we're going to get the edges for a node of start, right? And this returns a node here. Let's say dot name next start node. Key error 32. Object not callable. For edge, oh, it's a dictionary, right? Okay, for edge in diagraph.edges node start, where dict object not callable. Node start. Okay, int has no attribute object name. So this is going to give us a node. What? I don't. This is so stupid. For edge and diagraph edges. Int. What is an int? Which one of these is an integer? No. Diagraph.edges is keyed by hash code of the node name. Create a node object. Let's say current equals to node start, right? I'm going to say current hash diagraph.get current hash. What do you mean no attribute get? It's a dictionary. Oh. Oh, let's go. Do we get it here? Oh, I think we got it. Value error not raised. Value error not raised. So I'll say okay, so here and returns none. So we say in line 260 with self-directed DFS raises a value error for directed DFS. So if path is none, let me print the path here. Let me pray and here. Okay, so this is our path. This is our path. And we fail here. I don't think I'm getting it. Okay, I think we are close. Do that. If path is none, return raise value or return path. That's what I'm doing. Hey. Assert that value error is raised with directed DFS. We just returned the path. So we unpack. What? Your best path returns node, objects, and path. No, it doesn't return no objects. It doesn't. Stop lying. It doesn't. My path doesn't have node objects. That's what I'm doing. I'm doing that here. What the heck? This problem is so ridiculously annoying. I'm getting my... So if... Okay, so we'll say if path is none, then we'll say return. We'll say if best path, right? We'll do this, else return none. Now will that take care of it? this. We'll unpack it. Cannot unpack a none type. So if path is none, okay, so if path is none, we're going to raise a value error. Else we're going to return path index 0. Cannot unpack non-iterable untype. I was just trying to... I'm not unpacking a none. Why am I unpacking none? Type error. Cannot unpack non-int. So if best path equals to empty list, we're going to return none, none, right? Else we're going to return the tuple. So now this will get unpacked, right? We can say path distance. If path is none, raise, else return path. Come on! Let's go! Yes! Woo! Wow, what a problem. Holy crap. Similar difficulty to CS50X problems. Honestly, like these preliminary data structure here, class structure, you had to like really learn about each of their methods to figure out what happens. Because I was getting tricked up because it's so stupid. You call for so they have an error. They have a pretty bad error in my opinion. The error is right here. So why I was getting tripped up about a half hour ago on this whole indexing and key errors into the edges dictionary is, look, they are calling in the digraph object, they are calling get edges for node given a node object, and the node is the key of the edges dictionary. That is not true. This is not true, because they make a point up here to say that a node, this function is necessary so that nodes can be used as keys in dictionaries, even though nodes are mutable. So then in digraph, do we have a, they don't have a, they don't have a, like, an iterator or whatever it is, like a getter, right? They don't have a get function. They have this get edges, which doesn't appropriately index into the edges dictionary, because look, they say the edges is the node hash. In the add node to the edges, in the add edge, they use the edge hash from the node source hash. They're not doing that here. Okay, let's do this. I think that MIT has an error in their source code that was causing me issues. They say that edges dictionary are keyed by the node hash of its name, but in the get edges for node method, they do not use the node hash as the key. So I couldn't use this method without editing their code. So I had to use dict.get node hash, right, instead. You guys following what I'm saying? Yeah, your observation makes sense. The digraph class, as you showed, clearly stores edges keyed by node hash, not directly by the node object. So self.edges keys are node hashes integers. The get edges for node self node does not return self edges node. It does return self, but that expects a node key directly, which is a problem since the keys are hashes, not the node instances themselves. This mismatch causes errors when you call the get edges for node, because the node object isn't a direct key. The key is its hash. MIT's provided code seems inconsistent here. See, it should do this. We could easily change it to, it's just missing this right here. It's just missing this. Right? That's all it needs. But they don't have it. They don't have it. And we're told not to edit these. These were pre-existing. I'm sorry, Kabir, I didn't get your message yet. Let me go ahead and get into this now. I'm so sorry. All right, hey Michael, what's good, man? I'm legit so confused and kind of stressed about my career path right now. Could really use your brain power. So I've done some front-end stuff, but my pay is only like 10,000. Is that Indian rupee? INR? That's roughly 120 USD. I've done some front-end stuff. 120 USD. Is that per hour? That's a pretty good hour. That's a really good hourly rate, dude. Or is that 120,000 or what is the 120 in referred to, Kabir? I want to get a proper job, but I'm totally lost on what language to deep dive into. Wait, is your job only 120 USDs total? That's crazy. What's the move on getting high? Dude, Big dreams into getting into AI, but I'm currently starting from zero. No clue to where to even begin. Any chance you could drop a quick roadmap or point me to some killer study materials? Any help would be a lifesaver, seriously. Yeah, so I'm currently been teaching myself every single day from scratch. So if you're wanting to kind of follow a similar path to myself, I have a Discord link down below where you can get access to all of my resources that I've used so far. From every book I've read to notes I've taken, it's all within the Discord. Yeah. Christoph Codes. Hey, dude. Thanks for joining me. I appreciate you. All right, you guys. So now let's go ahead and see here. Implement the directed DFS. Uses the optimized depth first search for the shortest path. If multiples, return any one of them and raise a value error. Save your solution. At the start of each file, in a comment, write down your number of hours you spent roughly in the problems and the part of the number of people you collaborated with. Okay, so name, Michael Deming. Collaborators, YouTube / Twitch chat. And then time that we spent on this, we did about 3 to 4 hours. Okay. All right, you guys, I think that is the end of problem set 2. Woo! So we've completed. Oh, man, I was not expecting us to finish this one today, you guys, to be honest. I thought this one was going to be a lot harder. But, dude, this algorithm is tricky, man. There's just a lot of stuff. Like, it's just a lot of stuff you got to keep track of. You add the current node to the beginning, or the current starting point. If they're equal to one another, you hit your base case. You loop over all of the edges, right? You then get the destination edge. You increase the distances based on the destination edge, or the edge between, right, each destination. And then you have conditionals to check to make sure you don't loop back, you don't exceed the outdoor timer, and you skip the distance, you overwrite for smaller or greater distances, right? And then you do the recursive call on the new path that's created here for this current node here. Right, so you have the path of the node that you started on, and then you have to add the path of the node that you're looping over. And then you recursively call get best path on there. Man, yeah, that was tricky. That was tricky. YouTube chat's broken again? Oh, come on. Why? Dude. There's so many people in here. Oh, sorry. Yeah, there we go. Sorry. What? I don't know what's going on with social stream. I'm sorry, YouTube. Hey, Tim. I'm sorry, dude. Let's get caught up on the YouTube chat here. Who did I miss here? Hey Shadow Crush, how's it going, dude? Hey Marty. Hey Harshit, how's it going? Hi brother, can you please clear my confusion? What confusion do you have, dude? What's going on? Anita, how's it going? What do you think of Mojo IE Python superset? I've never heard of that before. What is that? I'm sorry if I missed your chats on YouTube. My social stream is being weird. I activated it, but it wasn't working. Whatever. We're 2 subs away from 2,800. So if you guys are new and aren't subscribed, please hit that button. Let's see if we can get that 2 subs, you guys. 2 away. Come on, 2 away. Come on, give me two. Give me two. Strike two. Strike two. Ball. Oh, Tim, you got to give your best, like, umpire. You got to give your best umpire. What is it like? What's your best umpire strikeout? This would be mine, like, ready? I'm going to come here. And then for a strikeout would be. All right, you guys. Cool. So I think that wraps up the MIT problem set 2. Okay. All right, so we were finished lecture 6 and we just turned in problem set 2. Okay, cool. So now problem set 3 is out. We'll watch confidence intervals and we'll watch sampling error, and then we'll do problem set 3. Then we'll watch understanding experimental data and do problem set 4. And then we'll watch these two, or these things, and then do problem set 5. And then watch this one, and then this one do final exam. Oh boy. We're almost halfway done, guys. It's going fast. What time is it? 9:04? You think we got time to watch a lecture? Should we watch one? Should we watch the next guy? Do we have enough juice? What do you guys think? Do we have enough juice to watch the next one? Are people feeling it? Are you feeling it now, Mr. Krabs? If you guys want access to this repo for the entire 6.0002 course I'm doing live on the stream, you can get access to all of my personal notes as I've been watching the lectures and my problem sets on my GitHub, linked in my description. Complete problem set 2. Sweet. Feeling good. Feeling good. All right. I am feeling decently motivated. I kind of want to start the next lecture. At least maybe we could start it. All right, lecture 7 is confidence intervals, I believe.
The following content is provided under a Creative Commons license. Your support will help.
All right, maybe we could at least watch the first half. I've got energy, I'm feeling okay, I want to keep moving. Okay, let's see here, let's try this. All right, let's go ahead and let me start up a recording here. All right, everybody, welcome back to the channel. Hope you're having a wonderful day so far. My name is Michael, and today, August 12th, 2020, today, August 12th, 2025, we're going to be jumping back into MIT OpenCourseWare 6.0002, Introduction to Computational Thinking and Data Science from fall 2016. We're going to be watching Lecture 7, Confidence Intervals by John Guttag. So this is going to be a great one, and I'm excited to get into this lecture on confidence intervals. We are watching this live. So if you are watching the re-uploaded version or the condensed version to the channel, consider joining us live every single day around 7 p.m. PST as I teach myself and do courses similar to these. As I teach myself, consider joining us live as I teach myself courses like this in computer science every single day around 7 p.m. PST. All right. Without further ado, we just completed problem set 2, and we are going to be jumping into the lecture 7 on confidence intervals. Let's go ahead and start it.
MIT or make MIT.
Welcome back to class. I have a lot to cover today, so I'm just going to get right to it. So you may remember at the end of last lecture, I talked about the empirical rule and said that there were a couple of assumptions underlying it, that one is the mean estimation error is 0, and second, that the distribution of errors will be normally distributed. I didn't probably mention at the time, but we often call this distribution Gaussian, after the astronomer Karl Gauss. And it looks like that.
Okay.
Normal distributions are very easy to generate in Python. I have a little example here of generating not a real normal distribution, but a discrete approximation of one. And the thing to really notice about it here is this line, random.gauss. So that's a built-in function of the random library. The first argument is the mean, and the second argument is the standard deviation, or mu and sigma, as they're usually called. Every time I call that, I will get a different, or usually a different random value drawn from a Gaussian with a mean, in this case of 0, and a standard deviation of 100.
Gotcha.
I'm then going to produce a plot of those so you can see what it looks like. And I'm going to do that using some things we haven't seen before. So first of all, we've seen histograms. So pylab.hist produces a histogram. Bins tells us how many bins we want in the histogram. I said we want 100. The default is 10. Dist is the values it will use for it. And then this is something we haven't seen before.
We're going to append a random sample.
Weights. Weights is a keyword argument. So normally, when we produce a histogram, we take all of the values, the minimum to the maximum, and in this case, we would divide them into 100 bins, because I said bins equals 100. And then we would, so the first bin might be, well, let's say we only had values ranging from 0 to 100. The first bin would be all the zeros, all the ones, up to all the 99s. And it weights each value in the bin by 1. So if the bin had 10 values falling in it, the y-axis would be at 10. If the bin had 50 values falling in it, the y-axis would go up to 50. You can tell it how much you want to weight each bin, the elements in the bins, and say, no, I don't want them each to count as 1. I want them to count as a half or a quarter. And that will change the y-axis. So that's what I've done here. What I've said is I've created a list, and I want to say for each of the bins, in this case, I'm going to give them, weight each of them the same way. The weight is going to be 1 over the number of samples. I'm multiplying it by the len of dist. That will be how many items I have, and that will tell me how much each one is being weighted. So for example, if I have, say, 1,000 items, I could give 1,000 values and say I want this item weighted by 1, and I want this item over here weighted by 12 or a half. We rarely do that. Usually what we want is to give each item the same weight. Mm-hmm. So why would I want it not to be weighted at just 1? Because I want my y-axis to be more easily interpreted.
Yeah, distribution.
As essentially giving me the fraction of the values that fell in that bin. And that's what I'm doing here. The other new thing I'm doing here is the plotting commands, including pylab.hist, many of them return values. Usually I just ignore that value and we just say pylab.plot or pylab.hist. Here I am taking the value. The value in this case for a histogram is a tuple of length 2. The first element is a list or an array giving me how many items are in each bin. And the second is the patches used to produce the beautiful pictures we're used to seeing. So here what I'm going to do is take this value so that I can do this at the end.
Sum the value.
Now why would I want to look at the fraction
Index
within
0.
approximately 200 of the mean? What is that going to correspond to in this case? Well, if I divide 200 by 2, I get 100, which happens to be the standard deviation. So in this case, what I'm going to be looking at is what fraction of the values fall within 2 standard deviations of the mean. Kind of a check on the empirical rule, right?
Okay.
All right. When I run the code, I get this. So it is a discrete approximation to the probability density function. You'll notice, unlike the previous picture I showed you, which was nice and smooth, this is jaggedy. You would expect it to be. And again, you can see it's very nice that the peak is what we said the mean should be, 0, and then it falls off, and indeed, slightly more than 95% fall within 2 standard deviations of the mean. Not even surprised that it's a little bit more than 95% because, remember, the magic number is 1.96, not 2. But since this is only a finite sample, I only want it to be around 95. I'm not going to worry too much whether it's bigger or smaller.
I think I am going to watch this tomorrow. I'm kind of running out of steam here, you guys. We solved the MIT homework problem here for problem set 2, but I'm running out of gas here, and I want to be able to pay attention and take good notes and stuff. I can feel my eyes just getting heavy here. I appreciate you guys joining me and hanging out with me today. I was super stoked that we were able to get through problem set 2. This one was really not. It wasn't like ultimately like something we've never seen or done before, so it wasn't like learning brand new material, but it was difficult in the fact that we had to use kind of pre-existing object-oriented programming, using classes and that are already custom made to actually incorporate and perform a depth-first search algorithm, not just on like a simple list or like a tree rather, but on like a custom created object, kind of linking together like a tree object from there with edges and things like that, weighted edges. So it did take us a few hours to kind of get through and kind of wrap our heads around to understand, but I appreciate you guys being here and hanging out with me for today. I will be back tomorrow around 7 p.m. PST where we will continue on. I plan on where we will watch this lecture tomorrow, and then I will go ahead and shift focus for the back half of the stream and start working on my Birdie Rose Close project. So a couple of days ago, we introduced a full stack project that we're going to be working on for kind of introducing kind of a more technical side, kind of transitioning my small business into more tech-based company rather than a more of like a storefront brick and mortar type of thing. So please be back tomorrow if you guys are interested in learning more about that. We have the potential to make money and revenue and kind of improve upon this already existing business that I have kind of going. So I'll see you guys tomorrow, and please join my Discord if you guys are new here. Subscribe. We're only 2 subs away from 2,800. We will continue on with MIT 6.0002 tomorrow and project work. So I'll see you guys then. Thanks so much for being here, and I'll talk to you guys later. Bye, guys.